Hello everyone, this is my final video update on the historic blizzard that is about to impact the northeastern US. For March, for this time of year, this is definitely a historic storm. So let's just start out with the satellite picture here, as usual. So I just want to point out that here is all your energy that has created the storm, and to the east, these brighter whites, these are high clouds. That's all this moisture and precipitation that is associated with this piece of energy back here that has created the storm. And then to the north, this is the main trough that's going to be guiding this up the coast rather than out to sea. And then you also have, here's your trough once more. You have additional moisture associated with the main trough, these brighter whites up in here. And then this is associated with the energy that actually created the storm. Okay, so that's the satellite. The other thing that I wanted to go over, really quick, just look at the extent, these brighter pinks, these are all winter storm warnings throughout the Northeast here. Look at the extent of those winter storm warnings. I mean, that is just pretty amazing for this time of year. Okay, and now in the red, all these red areas, those are all blizzard warnings. Pretty big storm, huh? I totally agree with that if I must say so myself. Okay, now going to our dynamics. Okay, so I'm going to zoom out. And we are going to go over the 500 millibar vorticity really quick, as usual. Sorry, I just clicked on 700. Give me a second here. Okay, and I want to change my color to blue. Okay, so here we are. This is this afternoon. This is the American model, the GFS. At this point, most of the models are pretty much intact in terms of the strength of this piece of energy down here that has created our storm. There's still a little variation on the exact track, though. There's still a little variation on how far east or west this storm is going to go. And that's a bit of a problem in terms of how far north and west the mixing precipitation is going to get, how far inland it will get. So that's problem number one. Problem number two, which I'll go over in a little while, is when you have a rapidly intensifying storm, the low pressure that's intensifying generates its own cold air. And so I think that on the northwestern side, some of the models are not taking that into account. And I think that's actually going to limit the amount of mixing that there is. I think there might be heavier snow in areas where the models are showing mixing because of this generation of cold air. Again, where the intensification process is happening. Okay, so as I pointed out, this is the energy that has created our storm. Here's your main trough that's guiding this piece of energy. And what's going to happen is that as we go forward, this trough is going to go to a negative tilt. Right now it's positively tilted. It is northeast to southwest. A negative tilt is northwest to southeast. So it's going to be changing to that. And what happens is, as that happens, this piece of energy gets sucked into a northerly flow and comes up the coast rather than goes out to sea. So let's go through that really quickly and see that happen. So just pay attention. Okay, later today, this evening, later tonight still, and tomorrow morning. Here we go. So now you see that the main trough is now tilted from northwest to southeast, so that's negative. Here's all your energy, and you can see that it looks as though it's going to go to the north and east now. And because this trough going negatively tilted sucks it into that northeasterly southwesterly flow, which drives it to the north and east. Another way to think about it is look at the isobars here, these black thin lines that are all pointing to the north and east. The storm, that piece of energy is going to travel in that same direction. So if you're having trouble visualizing it, then think about it that way. All right, so what's going to end up happening is this is going to continue to rotate around and rotate around. So let's see that happen. So you see this, you have these two pieces of energy. This is now rotated and is now has a really negative tilt. And this piece of energy, which was originally back down here across the Delmarva, has moved to the northeast and then shifted back to the north and west. So this is a very dynamic and complex multidimensional storm system, and that's why it is so hard to forecast. Okay, now the other thing to keep in mind is that because of this rotating back inland, and because this goes negative beforehand, you're going to be having moisture thrown back inland to the north and west. And that's the other thing that I think the American model, the GFS here, lacks a little bit, is how far north and west that heavier precipitation gets. I think the NAM and the European model have a better handle on that. Okay, so, not belaboring the dynamics part of it, let us go to the northeast here. And let's do American model instead of NAM. Alright, I'm going to go through this part pretty quick because I really want to try to keep this video under 15 minutes. Alright, so now we're going to look at upward motion as usual. Okay, so here we are. Let's go back. Alright, now we're at the same time frame. So here we are, the GFS. So we have all this upward motion here that's starting to move northward. So you're starting to snow southern Pennsylvania, and Maryland here, northern Delaware, northern Virginia. You are starting to snow by later this evening. Okay, let's continue to move forward. See that upward motion starts to move further northward later tonight. And see by daybreak we have all this upward motion across central and eastern Pennsylvania, northern New Jersey, and the lower Hudson Valley, New York City, and western Long Island. So now you are getting really heavy snow at this point, and I will show that here. So first off, later tonight, that upward motion, which was originally across southern and eastern Pennsylvania, so now Philly, Baltimore, and even D.C. down into here, you're starting to get heavy snow after midnight tonight. But as you move forward, that is going to shift to the north and east, and that upward motion here picked up in intensity a little bit. So now look at all this. Darker shades of blue. So heavier snow is really starting to pick up as this storm starts to intensify. The precipitation on the northwestern side starts to pick up rapidly. Okay, moving forward, look at this. The upward motion continues to move to the north and east. And so does the heavier snow. Now this purple here actually represents heavier snow, according to the map. This is not mixed precipitation here. Purple, this purple coloring is actually heavier snow. So you can see, look at this thing of upward motion here. And you could see that over Philadelphia, you are picking up pretty heavy snow at this point. Okay, now, because I don't want to belabor this a little bit, I am just going to say, instead of showing, that the NAM has this type of upward motion that you see across southeastern Pennsylvania here. It has this spread all across, did not mean to zoom in. hold on. All right, there we go. So the NAM has upward motion all across central and eastern Pennsylvania and heavier snow spread out all across this area. And I agree with that a little more than the American model, because I think as the storm intensifies, it's going to throw that heavier precipitation back, and I think there will be more upward motion spread further inland than the American model is saying. But as we go north and east, just check this stuff out. This is true. I believe that all of this upward motion is going to be here across the lower Hudson Valley and New York City, western Long Island, and this will be spreading. This is by mid-Tuesday morning. I still think that there's going to be upward motion back across central eastern Pennsylvania and up into the Hudson Valley into central and northern New York as well. And then later on, it'll move on towards Vermont, New Hampshire, and Maine, as you'll be able to see when I go one more step forward here. See, moves to the north and east, and it just, it's pretty intense. Okay. Sorry, I did not mean to do that. Okay, so now, by mid-Tuesday morning, take a look at all this bright purple. That's very, very heavy snow. Okay, so now here's the difference between the models. So first off, the GFS is a little further to the east. But second off, you see how the rain and snow line is still really confined to the extreme coast. Well, the NAM has it all the way back up into Westchester County. And see, I think that as this low intensifies, that the GFS is right, that this will generate its own cold air, and I think that this is probably mainly going to be snow. I don't think it gets back as far north and west as the European and GFS are saying. So that is why my snowfall map is what I'm about to show you. So let's just wait so I can pull this up. Oh my goodness. Hold on a second. Goodness gracious. Sorry about that, folks. Okay. All right, I need my final snowfall map. Here it is. Okay, sorry for those technical difficulties. This video is going to end up being really long. So let's just go through this pretty quick. So anybody inside this purple line, I think on the northwestern side of the low, as it's rapidly intensifying, you're going to be throwing all this moisture back, and you're going to get intense snow bands on the northwestern side. So anybody in here across northeastern Pennsylvania, extreme northwestern New Jersey, and the middle Hudson Valley, into portions of the lower Hudson Valley here, into western Massachusetts and Litchfield County in northwestern Connecticut, I think we're going to get 24 to 30 inches in these areas, 2 feet plus. I would put Binghamton in the 24 to 30. I'd put Poughkeepsie in the 24 to 30. I'd put Worcester in the 24 to 30. Albany, I think you're a little too far north. I think you're more like 18 to 24 inches. But some areas in here, I think somebody in here is getting 3 feet. I honestly do think somebody in that area is getting 3 feet. Okay, let's keep going here. Philadelphia, we're going to go 12 to 18. Baltimore, we're going to go 6 to 12. DC, I think you're closer to 6 inches, but we'll say 6 to 12 for now. Boston, we're going to go 12 to 18. All of coastal Maine, we're going to go 12 to 18. Okay, I said Albany, we're going 12 to 18. Sorry, I mean 18 to 24. Most of central and eastern Pennsylvania, we're going to go 18 to 24 inches. Central and northern New Jersey, New York City, 18 to 24 inches. Most of central Connecticut, including Hartford, 18 to 24 inches. West, this is where it gets tricky now along the coast. All right, I'm going to try to finish this in 45 seconds. Along the coast here, depending on how far north and west mixing comes, these numbers could be a little off. But I'm going to go for western and central Long Island. We're going to stick with 12 to 18 inches. If mixing occurs, you will be closer to a foot. If the cold air gets generated and it's more snow, you will be closer to 18 inches. Central and eastern Suffolk County, we're going to go 6 to 12. I definitely think mixing is coming into central and eastern Suffolk County. Now, in southeastern Massachusetts and southeastern Rhode Island, we're going to go 6 to 12. Providence, I think you're 12 to 18 inches. And out on Cape Cod, I think you're going to get ripped off pretty bad. I think you're going to change over to a period of rain for quite a while, so I think you're less than 6 inches. And even across the Twin Forks of Long Island, don't be surprised if you get around 6 inches or less. Okay, so that is the forecast. Also, a good part of Northern Virginia, we're going to go with 6 to 12. Northern Delaware, 6 to 12. South of there, less than 6. Cape May, everybody down here, less than 6, because you're going to be mixing with and changing over to rain. Pittsburgh, we're going to go 6 to 12 for you. You're way too far west for the heaviest snow. All right, I think I covered everybody. Most of western New York State, we're going to go 12 to 18 inches. And keep in mind that anybody in the 12 to 18 could locally pick up 2 feet, and anybody in the 18 to 24 inch area could locally pick up 30 inches. Okay, especially in here. In this area, and I'm not trying to zoom in. Just draw and zoom can get annoying sometimes. But anybody in here on the northwestern side of the low, this is where you're likely to pick up localized higher snowfall amounts. Okay? Thank you for watching. I'm sorry the video is so long, but this is a very complicated forecast. So hopefully this does not become a total bust. Thank you for watching.